Hello and welcome everyone. I'm Tropin and I work on operating system and programming languages and do a lot of free and open source software along the way. Today we discuss a topic about reusable threads. This is a small sub-project that appeared during the implementation of nrepl protocol in Guile. Reusable threads is a nice tool when you want to spawn thread only once and send a different procedures to it for the evaluation. Original threads, let's start from the API that I have. The usage is very simple. We just create a reusable thread which accepts two arguments. First one is shutdown condition, which we can signal to make thread finish after the sync inside it completed. And the second one is finished condition, which will be signaled by the thread when it perform all the operations scheduled. That's it. Actually, those two arguments are almost optional. The thread will work without it. The second thing that we have is a function, a reuse thread, which accepts a reusable thread and a thunk. A thunk contains a procedure which will be evaluated on this thread. And that's basically it. So we create a reusable thread. We just schedule a thunk for evaluation, and we can obtain a result and wait until the thread is finished and check it is finished. That's pretty much the whole API. But the implementation a little bit more interesting. And I will share details of the implementation because it contains a couple of interesting things and approaches that were emerged during the work on this small project. First of all, a reusable thread consists of two important parts. The first one is synchronization point, and the second one is the thread itself. Of course, we need like a POSIX thread, which already covered by Guile, but we need to make an interface on top of this POSIX thread. And for some reason, we need a synchronization point to make the access from different places to the same reusable thread synchronized. So we don't interrupt concurrent threads which run in parallel in unpredictable way. We already have in a Guile system async mark function, which basically schedules a procedure in a particular thread, which almost the thing that we want out of reusable thread. The problem here is that after this procedure evaluated, the previous computation is resumed. So the previous computation is not interrupted. But what we really want is to interrupt the previous computation, so we get a new computation evaluated, and after that we expect thread to be suspended. And there are a few things that we can do about it. First of all, let's discuss how we can implement the interruption of evaluation. We can do it with delimited continuations. The delimited continuation is discussed in a couple of previous streams, and also I have a post about it, so you can find it somewhere here. It has all needed information, but I will do a very small recap on delimited continuations, and API for it we have in a Guile. We can use call this prompt function, specify the prompt, and after that we have a 0 argument function which do something. And also we have a handler which accepts a continuation and arguments, which can either call this continuation or ignore it. And inside thunk, we can do abort to prompt, which basically stops the evaluation at the current point and goes to the delimited continuation handler. So let's see. We have abort to prompt tmp. Here we will do format true something \n, and after abort to prompt we will print something else. So in the usual scenario, the both things should be printed, but because we do abort to prompt and we'll jump to the handler which doesn't use continuation anyhow, the second part should not be printed. And let's try. I will do a sleep at the end for some reason. Okay, it works. It prints something and it says 0 values returned to single valued continuation. Okay, let's do this. Right. Very good. We have one thing printed and another thing not printed. And of course we can reuse continuation and call it with some argument. And in place of this thing we will get a value 1. And after that the second part should be evaluated as well. So right now we will get something and something else. That's right, you can see it on the right. That's, I think, enough information about delimited continuations, so we just use it as a simple go-to outside of this computation. And the reason we use the streak, we need the streak, is because when combined with system async mark, we can schedule a procedure which do abort to prompt. And that means if we don't call a continuation here, it will abort the whole computation. So this way we can implement the interrupt for current computation. That's very neat. The only problem is following. If two independent threads at the same time will try to schedule with system async mark a procedure that calls abort to prompt, we will get a problem. The problem is following. When we do the first abort to prompt, we come to the handler, and in this handler we already not in the context of a delimited continuation, not in the context of the prompt. So the second call to abort to prompt will fail because there is no such prompt at the moment here. And to prevent this thing, we will do a synchronization. So we will do access to the reusable thread synchronous. When you schedule a computation with reuse thread function, we should prevent two separate threads to do it simultaneously. And for this, we need to use some synchronization mechanism. The synchronization mechanism could be a very simple mutex. But I have a constraint. I need to use this API, this reusable threads, inside fibers. And inside fibers, I can't use mutexes. I can't lock mutexes because if I lock mutex inside fiber, it will suspend the whole kernel thread, which is not acceptable in my situation. So I need to implement mutex-like mechanism using something else. And it's done using conditional variables and atomic boxes. The conditional variable which we put inside atomic box will be telling us if the thread is ready for the queries, for reuse thread queries. If it's true, we can do our reuse thread query. If it's false, that means that some other fiber or thread tries to schedule its computation. So, before doing a reuse thread, we need to lock a synchronization point. And if it's locked, we can actually schedule our thunk for the evaluation, for execution. And after we scheduled it with system async mark here, we can signal a synchronization condition, and this will allow other threads to call reuse thread and continue work to get this lock and to schedule another computation using this trick. As you can see, we schedule a computation using abort to prompt and sending arguments to abort to prompt. That's because of how internal loop of the thread is implemented. So inside our thread, we have a simple loop which waits for a command, and if the command action is run, it just creates a prompt, and inside this prompt it executes a thunk. That's basically it. This is a most important and most crucial parts of the implementation. This simple trick to implement a synchronization mechanism without mutex works quite nice. Probably you can ask what atomic box update does. I explained it in a previous stream on the concurrency patterns in Guile, but let's revisit it quickly. This is a simple function which tries to set a new value for the box, and this value is computed from the old value. So how it works? We have a loop, we obtain the old value, we produce a new value by applying procedure to the old value, and after that try to update the value with atomic box compare and swap function. And if it succeeds, we just return a new value. If it doesn't succeed, we repeat the cycle and do it until we succeed. So here, obtaining a lock on synchronization point works almost the same way. We get the value of the old condition in the atomic box, which should be true, and when it becomes true, the wait unlocks, and we try to save a new condition to atomic box. And if we succeed, we get out of this function and we can do our work, because nobody else now will access our thread. That is how we implemented the synchronization point, the lock for synchronization point. There are a couple more technical details. For example, here inside the thread itself, we use a lock mutex to suspend the thread when the thunk execution is finished. Because if we don't suspend the thread will be finished and we won't be able to reuse it. So every time the thunk completed, we lock the mutex. And only way to finish the thread is to unlock mutex somehow. And the unlock mutex can happen inside the fiber. Inside the fiber, if we see that shutdown condition is signaled by someone, we just unlock the mutex. That's it. And as a conclusion, I would like to say, even if there is no built-in API for reusable threads in Guile, we still can implement it relatively easy. It took some time. The implementation is not perfect and it tailored towards a specific use case. But overall, you can adjust it to your particular use case and it will work. The source code for it you can find in Guile RS project, which previously known as Guile nrepl. Here in src nrepl server evaluation. And here, reusable thread. Here you can find the implementation, the tests in the relative directory, in tests nrepl server evaluation test SCM. Okay, that's it for today. I hope you enjoyed and I hope it was useful for you. If you have any question, ask me in Mastodon or email, and see you in a bit. Bye.